Welcome back to Ubad's lab, and today I'm going to be explaining how to find the concentration of all the reactants and products at equilibrium. Alright, let's start with the information that we're going to be given in this problem. So we know that the reaction is H2 plus I2 goes to 2HI, and this is an equilibrium reaction. We know by the symbol right here. And we're given the equilibrium constant K, which is equal to 100. And then we're also given the initial concentrations of everything. I'm going to be writing that down in a little bit. And the question is, what are the concentrations of everything in this reaction once the reaction reaches equilibrium? And the way that we're going to be finding that is by setting up an ice table. And let's start off by setting up our ice table. So the I stands for initial concentration, and then the C stands for change, and then the E stands for equilibrium. So the initial concentrations of H2 is 0.010, and the initial concentration of I2 is 0.005, and the initial concentration of 2HI is 0.500. And this is all in molarity, by the way, so you could put brackets around these, but I'm just going to leave it like this. And now we're going to have to find the change. And before we write down the change, we have to find which way this reaction is going to be shifting. And the way we do that is by calculating Q, which is it's basically finding the equilibrium constant, but using the initial concentrations, so we can find which way the reaction is going to shift. So we know Q. I'm going to do it over here. So Q is equal to the products minus the reactants, divided by the reactants. So we know that the product is 0.500. We can put parentheses around these, and we have to square it because the exponent becomes whatever the coefficient is. So we put a 2 over here, and then we divide by the reactants, which H2 and I2. So, and we're going to multiply them. So 0.010 multiplied by 0.005. And there's no coefficients, so we don't have to square them or anything. And if there were more products, then you'd multiply the products inside the numerator. And then we find out that Q is equal to 5,000. And we're given that K is equal to 100 and Q is equal to 5,000. So we know that Q is greater than K. And with this information, we know that the reaction is going to shift to the left towards over here, and these are going to be the products. Since it's going to have to compensate and go towards the left. And if K was greater than Q, then the reaction will shift to the right. So we can start off by writing the change. So since the reaction is going to be shifting towards the left, we know that the changes on this side are going to be positive, and this side is going to be negative, since it's going to be decreasing in concentration on this side and increasing in concentration on that side. So let's start off by writing down our changes. So this is just going to be plus x, since there's no coefficient, just a coefficient of 1, so just x, and plus x, again, just like that. And over here, it's going to be minus, since it's decreasing, and 2x, since it's a coefficient of 2. Alright, and now we can start by writing down our equilibrium concentrations. So to do that, we just add the initial concentration plus the change in concentration equals the equilibrium concentration. And that kind of makes sense because it's just looking at whatever your initial concentration is, seeing what the change is, and from there on you can find what the equilibrium concentration is. So for H2, it's just going to be 0.010 plus X. And then over here, it's going to be 0.005 plus X. And then 0.500 minus 2X. All right. And now, using this, we can use some basic algebra to solve for the variable X. And the way we do this is to set up a equilibrium constant equation. So we know that K is equal to products over reactants. So the products is 0.500 minus 2x. And this is squared since there's a coefficient of 2. And it's divided by 0.010 plus x times 0.005 plus x. And we know that K is equal to 100. So you can just like either solve this algebraically, or if you have a TI-89, I remember we used to do this in chemistry class a lot, just plug into TI-89 and solve it that way. But you do find out that the X is equal to 0.035. And we're not done yet, because the X is just the change. We have to find out what the equilibrium concentrations are. So the equilibrium concentration of H2 is equal to the X plus 0.010. So it's equal to 0.045. And for I2, it's equal to 0.005 plus X, which is 0.035. So we get 0.040. And for HI, we have 0.500 minus 2x, and x is equal to 0.035. So if you just plug that into this expression, we get HI is equal to 0.43. And these are the concentrations of the reactants and the products in this equilibrium reaction once the reaction reaches equilibrium. Alright, I just broke my mic adapter. So what happened was that my phone was still on my tripod and it fell over, and my mic was plugged in, so the adapter broke into two pieces. So aside from that, don't forget to follow me on Instagram, because I post a lot of cool chemistry related things on there, and the link will be in the description. Also stay tuned for my next video, where I'm going to be making sugar crystals, but I won't be posting that until I get my mic fixed.